Okay. So today what I planned, because see, from this chapter you will be getting the numerical portion, right? But somewhere we are lagging behind in the numerical portion. So what I am planning today, I will cover all the theory things. I hope you people can see my screen, right?
Yes, ma'am.
So today I will cover all the theory portion of this chapter. Okay. And then somewhere in just one simple page, we will be writing the formulas of everything, right? For speed, for average speed, everything. And after that, from tomorrow onwards, we'll start with the numerical. So I will take your 1 or 2 class for the numerical where we can discuss each and every question. Is it fine? Do you want me to do it like this? Like first, let's just cover the theory portion, like just understand the terms and all that, and after that the next class we'll discussing only the numericals. Like for example, the first formula we have average speed, so 2 questions for that, then average velocity, 2 questions for that, like this. Or do you want me to teach you like this, like ma'am, the way I was teaching you, explaining average velocity then numerical, explaining next concept then numerical, like what is sufficient for you or what is convenient for you? Tell me.
And we'll do the numericals at one time, and then we'll write the formulas all in one page.
Sorry, Jocelyn, be loud. Like first theory and then numericals.
Yes, ma'am.
Okay. Ayan, Mohammad Adil and Jeba. First one.
Yeah, same thing.
Okay. Jeba, I hope you are also fine. Yes. Jeba, you can write it down on chat box if your mic is not working. Okay. So now just quickly from starting itself, we'll just discuss what we studied in the entire chapter. Okay, because that will be a revision. And today we will cover all the theory portion. So then I'll ask you to write all the formulas on one page and then the numerical portion. So first of all, when we started the chapter, the very first question was, ma'am, what is motion? So motion is basically, you can take out your notes, right? So what is motion? Movement of an object from one place to another with respect to origin is called motion. Okay. So when your one object is moving from one place to another, that is your motion. Okay. Maybe I'm traveling from this to this. So this is my motion. Then we studied, ma'am, distance, and the other we studied displacement, right? So somewhere distance and wait, I just somewhere distance and displacement, they are brothers, right? So ma'am, what is distance? Length of a path, you can say, and displacement is the shortest distance. Distance is basically the total movement, and this is basically, you can say, the shortest distance between the initial point and the final point or the position. Distance cannot be zero, but your this displacement can be zero. And when can it be zero? When your initial and the final position are same. Distance is a scalar quantity and displacement is a vector quantity. Clear the difference between distance and displacement? Say yes or no.
Yes, ma'am.
Yes.
Then we studied this, like when displacement is, this is basically the crisp notes. It's not the detailed one because you have your book for that. Okay. Displacement and distance. So ma'am, when your distance is greater than displacement, that means you are traveling in a straight line. Okay. Always, whenever your displacement is more than or it is equal to distance, so it is like you are traveling in a straight line. Then we studied over here two things. One is scalar quantity and one is vector quantity. So ma'am, what is scalar and what is vector? So when magnitude is given but no direction, that is known as scalar quantity. And vector, when both magnitude as well as a direction are given, that is a vector quantity. Examples are distance, speed, and mass. These are example of scalar. And who is the brother of distance? Displacement. That is a vector quantity. Who is the brother of speed? Velocity. And who is somewhere mass and force? So it is vector. Clear? Yes, no,
Yes.
others?
Yes, ma'am.
Okay. Now next we did types of motion. So there are two types of motion,
Yes.
uniform motion, okay, and non-uniform motion. Uniform motion means your speed is constant and here speed changes. Equal distance and equal interval of time. You are covering equal distance plus equal interval of time. But here unequal distance and equal interval of time. So time is going to be same. But here you are covering equal distance. That is, for example, if you are covering 1 kilometer, that means equals to for every like 2 kilometer, then 3 kilometer, 1 hour, second hour, third hour, like this. But here it is like you for first hour you are completing 2, then for second you are completing maybe 3, second hour. For here you are completing 6. So you can see it is changing, right? So it is unequal distance. Then we studied about speed. So ma'am, what is speed? Basically, speed, the SI unit. SI unit I'm not discussing right now. I have given you questions. So ma'am, what is speed? Speed is basically how you are traveling along distance. And when we talk about average speed, that is total distance travel divided by total time taken. Your average speed is denoted by V and total distance is denoted by S, and your time taken is denoted by T. Then we discussed about velocity in the previous class. It is the speed of the object moving in a definite direction. So if you are moving in a particular direction, over here direction is given. Okay. So that is known as velocity, and average velocity displacement upon time taken. And what was your speed? Total the distance travel upon total time taken. Over here, your total displacement upon total time taken. This is what we did. And then we did this. I think this we did, right? Difference between speed and velocity.
Yes, ma'am.
Yes. So this is difference between speed and velocity. So total distance traveled in a given interval of time. That is speed. Displacement of an object. This is total displacement. This is basically total displacement of an object in a given interval of time. Speed is a scalar quantity. Velocity is a vector quantity. Speed can always be positive, but velocity can be positive, negative, and zero. This is clear. Till here it's clear.
Yes.
Yes, ma'am.
Now the next topic is rate of change of velocity. So during uniform motion of an object along a straight line, the velocity remains constant with time. In this case, the change in velocity of an object for any interval is zero. Okay. So see, velocity. Now the question will be, next question will be, when your velocity is zero, when will, as you know, when we were discussing displacement and distance, right? There was a question when your displacement will be zero. Was there a question? It was right. When your displacement will be zero. Wait, I'll show you with this one. So when your displacement can be zero, when your initial and the final position are same, right? Similarly, you will get a question like this: when your velocity will be zero. As over you have mentioned that velocity can be zero. So the question is when your velocity will be zero. So during a uniform motion of an object along a straight line, the velocity remains constant with time. In this case, the change in velocity of an object for any interval of time is zero, right? So in this case only your velocity will be zero. Okay. Or they can ask you whether in uniform motion or non-uniform motion velocity will be zero. So in uniform motion, only your velocity will be zero. However, in non-uniform motion, velocity varies with time. Non-uniform means somewhere you are like 2 kilometer per hour, here you are 3 kilometer per hour, here you are 1 kilometer. So it is changing, right? So, however, in the non-uniform motion, velocity varies with time. It has different values at different instant and at different points of path. Thus, the change in velocity of an object during any interval of time is not zero. Okay, so now you will write the question. When change in velocity of an object is zero. When change in velocity of an object is zero. When change in velocity of an object is zero. When change in velocity of an object is zero, then from here during a uniform motion you will write it here till here.
Finished, ma'am.
Okay, are this done?
Yes.
Now the question is, ma'am, what is the difference between velocity and the rate of change in velocity? Right? So of course there will be a difference. Now that's why it is rate of change. So basically this rate of change of velocity is known as some terms. Okay. And what is that terms? That term is known as acceleration. Okay. Clear? Yes, no?
Yes,
Yes,
ma'am.
ma'am.
So next
Yes.
heading will be acceleration. Now what is acceleration? Rate of change of velocity is known as acceleration. Non-uniform motion is caused because of acceleration. You will write entire thing. Because of acceleration, non-uniform motion is caused, and this acceleration is a vector quantity. Clear?
Yes.
Clear? Okay. So you will write it down, hashtag, and these things. Okay. Adil and Jeba done?
Yes, ma'am.
Yes.
Okay. Now you will write the formula overhead. Acceleration equals to change in velocity upon time taken. Okay, so right now we are not discussing anything like what is this, what is that, because we are focusing on only theory portion. So write this formula. Yeah, this one. And side by side, you will write it over here. Right, V minus U quantity like this. Then we'll discuss what is V and all. And then you will write where initial value, okay, final value is V. This is your initial point, I, and this is your, you will write where V equals to like somewhere like this, it's equals to initial value, and this is final point, and T is basically the time.
Done, ma'am.
Done.
Okay. Everyone is done? Done? Everyone who is left? Jeba done? Jocelyn is done, right?
Yes, ma'am.
Now see, if an object travels in a straight line and its velocity increases or decreases by equal amount of in equal interval of time, then acceleration of an object is said to be uniform. So now the question is, acceleration can be of two types, uniform and non-uniform. Okay. So when it will be the uniform one, if the velocity increases or decreases by equal interval of time. Okay, that is uniform. But when your velocity is increasing or decreasing by unequal amount of unequal interval of time, then it is said to be non-uniform acceleration. Clear? Clear? Yes,
Yes.
or no? So you will write next hashtag like this, write it down, and then just write types of acceleration. Types of acceleration here uniform and here non-uniform. So you are going to make it a like your own statement. If an object travels in a straight line and its velocity increases and decreases by equal, just write by equal interval of time, then the acceleration of object is said to be uniform. And opposite you will write, if an object travels in a straight line and its velocity increases or decreases, okay. Or you can just simply write an object can travel with a non-uniform acceleration if its velocity changes at non-uniform rate, or you can write it like this one. Okay. Which I think this one will be more sufficient for you. If an object travels in a straight line and its velocity increases or decreases by, instead of writing equal, you will write unequal. Unequal interval of time, then the acceleration of body is said to be non-uniform. Clear? No?
Yes, ma'am.
You want me to repeat it? How you will write? You will write hashtag types of acceleration, uniform and non-uniform. First, you will write the definition of uniform. If an object travels in a straight line and its velocity increases or decreases by equal interval of time, then the acceleration of a body object is said to be uniform. And opposite, what you will write, if an object travels in a straight line and its velocity increases or decreases by unequal interval of time, then the acceleration of an object is said to be non-uniform. Okay, quickly write it down. Others done?
Done.
Okay, Adil done? Oh, okay. Now, this is a graphical representation of a motion that I will be discussing with the numerical itself. Okay. So right now, what you have to remember is that how your graph look like. Okay. So see, first is your time, distance and time graph. So your distance and time graphs looks like this. So what you will write, just you have to make a short note. So graphical representation of motion. Okay. So first you will give a heading, hashtag graphical representation of motion. And then you will write first distance time graph and you will draw it like this. I hope you have your pencil scale. You just simply, you have to draw it like this. Okay. So you can see here you have to represent time and this is your D, which is your distance. Okay. Time is in minutes and your distance is in kilometer. Okay. Clear?
Yeah.
So first you will write hashtag graphical representation of motion. First, time, distance, time graph, and you have to draw a good diagram. It's not like randomly drawing it like this. Use scale and pencil. Okay, like this. And write proper heading. The numbers over here you can see. Okay, just draw it and let me know once you are done. First, write graphical representation of motion. Others done? You have to write this statement. Distance time graph of an object moving with uniform speed. So why it is like this? Because the object is moving with a uniform speed. That's why only this is like this. Okay, so write it down and then we'll quickly move to the second part.
Done.
Done, ma'am.
Okay, good. Now you will draw this one like this. It will start from here, but it will move like this. Like you can see it. This is a distance time graph. Okay, what you will write? You will write distance time graph of an object, or you can write for a car moving, or you can write of an object moving with non-uniform speed. Clear?
Yes.
Of an object moving with non-uniform speed. So don't forget to mention this time. Over here it is in seconds and distance it is in meter. Where distance time was in, see, if you are taking kilometer, then you have to take minutes. If you are taking meter, then you have to take seconds, like this. Done, students?
Yes, ma'am.
Yes.
Okay. Everyone is done?
Yes, ma'am.
Now, the second one, like the first way which we did this distance time graph. Now, the second one is velocity time graph. Okay. So, it is like this itself. This. And this will be moving like this. This is your velocity. This is your time in hours. This is in hours right now. Okay. And this will be in kilometer per hour. Kilometer per hour. Okay. Because this is velocity. So, always remember speed and velocity, they are like this. 8 kilometer per hour. You cannot say your speed is 8 kilometers, right? It is like this only. And similarly, fifth velocity. So this is velocity is in kilometer per hour. They have written it like this, kilometer minus 1. You can write it like this, kilometer per hour. You don't have to. If you are not writing minus 1, that means you can write it like this. Okay. So you'll put second velocity time graph this. And here velocity time graph for uniform motion of an object.
Done.
Others done?
Yes.
Now, see. Wait. So velocity time graph for a car moving in a uniform acceleration. See, over here, wait. first let's just cover this then. Now it is a velocity time graph. Okay. So over here you can see velocity time graph for a car moving with uniform acceleration. It was uniform motion. Over here it is acceleration. So this will be your graph. Clear? So just put it, just draw this graph and write this. Clear?
Yes, ma'am. Done, ma'am.
Okay, others done.
Done.
Now the last thing, last graph, velocity time graph of an object in non-uniform accelerated motion. Okay, so these two graphs. So like this, one is like this, it is moving downward, and second you can make it like this, zigzag. Okay, quickly just draw this graph and just write this. So we'll be done with all the graphs. So if I'll ask you how time, distance and time graph look like, you should remember the graph, exact graph. Okay. So you should not like, oh my God, what was this? So you have to learn the graph, how they look like.
Done, ma'am.
Okay. Left. Okay. Done. Okay, great. So now we are left with the equations that we will cover tomorrow because that will take time. And tomorrow